In this video, I'm going to be talking about something called a confounding variable. A confounding variable is a certain type of extraneous variable, and it's an extraneous variable that's unequal across the conditions of an experiment. So, a confounding variable is something that isn't being studied by the researcher, and it might affect the results, and it's also unequal across the conditions of the experiment. And based on what I've told you in the last video, you're probably already thinking that a confounding variable is something that you don't want in your experiment. It's something that a researcher doesn't want to end up having. It's something the researcher wants to avoid. And if that's what you're thinking, you're correct. A researcher wants to avoid having any confounding variables in an experiment. And a confounding variable is correlated with both the independent variable and the dependent variable, which is something I'll explain more once we get to some examples. And a confounding variable lowers the internal validity of an experiment. So a confounding variable prevents the researcher from confidently reaching a cause and effect conclusion at the end of an experiment, which isn't good, right? A researcher wants to be able to confidently reach a cause and effect conclusion. So now let's go to some examples of confounding variables. So here's my first example, and here we have an imaginary experiment, and this is actually the same experiment that I showed you in the last part of the video. So in this experiment, the researcher wants to know wants to test whether sugar improves memory. So the researcher randomly assigns the participants to two groups, and one group gets 50 grams of sugar, the other group gets no sugar, and the researcher gives all participants a recall test, and then the researcher compares the mean recall score of the sugar group with the mean recall score of the no sugar group to find out which group did better at the recall test. And in this experiment, let's imagine that the researcher accidentally gives the sugar group 5 minutes to take the recall test and accidentally gives the no sugar group only 30 seconds to take the recall test. So let's imagine the researcher wanted to give the two groups the same amount of time to take the recall test, but the researcher accidentally gave the two groups different amounts of time. Well, in this experiment, recall time, or the amount of time people have to take the recall test, is a confounding variable because it's not being studied, it's extraneous, and it might affect the results, and it's also unequal across the conditions of the experiment. The 50-gram condition got 5 minutes to take the recall test, and the 0-gram condition got only 30 seconds to take the recall test, and they were rushed. So this recall time variable is an extraneous variable that's unequal across the conditions. So it is a confounding variable according to our definition, and this confounding variable is going to this confounding variable is going to lower the internal validity of this experiment, and it's going to prevent the researcher from confidently reaching a conclusion about the effect that sugar had on recall, because if this turns out to be the researcher's results, and the researcher ends up seeing that the sugar group did better than the no sugar group, then there's actually three possible reasons why the sugar group did better. It could be they could have done better because of the sugar, they could have done better because they had 5 minutes to take the test, and they could have done better for both reasons. So their higher performance could be a combination of the sugar and the 5 minutes to take the test. And any one of those three possibilities could be the truth. It could be the sugar, the extra time, or both, and the researcher is left in the dark. The researcher doesn't know the exact reason why this first group did better on the recall test, and the researcher can't arrive at any conclusion. So that's why a confounding variable is a problem. If an experiment has a confounding variable and there's an extraneous variable that's unequal, the researcher can't confidently arrive at a cause and effect conclusion because there's more than one possible explanation for the data. And this isn't this isn't the situation a researcher wants to be in. So I'm going to move on to one more example, but before I move on, I wanted to mention what the word confounding means in everyday life. The word confound means to confuse. If someone is confounded, then they're confused. So in this experiment, the researcher who gathered this data set is confused because the researcher knows that group one did better and that they have the higher average score, but the researcher doesn't know if it's because of the sugar, the 5 minutes to take the test, or a combination of those two things. So now, let's move ahead to my second example. Let's now imagine that a researcher wants to test the effect of study method on exam performance or exam score. And more specifically, the researcher is interested in whether students who spread out their studying tend to do better than students who cram for an exam. So the researcher randomly assigns the participants to two groups, and one group is asked to cram 8 hours the night before the exam, let's say between 9 p.m. and 5 a.m. The second group is told to also study 8 hours, but to study 2 hours per day over a 4-day period and spread out their studying. And the researcher compares the mean exam score of group 1 with the mean exam score of group 2. And let's imagine that the researcher ends up getting this data set that we're looking at right now, and the cramming group does do more poorly, and the no cramming group does do better, just like the researcher predicted. Well, the researcher might be tempted to conclude that the first group did more poorly because of the crammed, rushed study session, but the researcher can't confidently reach that conclusion because it might not be the cramming itself that led to this poor performance of group 1. Notice how this group crammed for 8 hours on the night before the exam, and they basically did an all-nighter, which means that this group might have had 2 hours of sleep on average, whereas the group that spread out their studying 2 hours per day probably got more like 6 hours on average the night before the exam. So what the researcher has unfortunately ended up with is a confounding variable, which is hours of sleep the night before the exam. So the researcher is comparing a group that crammed and a group that didn't cram, but at the same time, the researcher is also comparing a tired group with a more well-rested group. And in this situation, the researcher is once again left in the dark because the researcher doesn't know if the poor performance of group 1 is due to cramming, the 2 hours of sleep, or a combination of both. And any one of those three could be true, and the researcher can't decide between those three possibilities. So what the researcher should have done in this experiment is maybe told group 1 to cram for 8 hours during the day before the exam, maybe between 9 a.m. and 5 p.m., and told group 2 to study 2 hours per day over a 4-day period during the day also. That way, the two groups would have the same amount of sleep on the night before the exam, and the only difference between the two groups would be the cramming and no cramming. But the researcher didn't think of that, and now the researcher unfortunately ended up with this inconclusive experiment.